thing that over time that has always excited me is the following, that I like thinking about algorithms, is designing algorithmic solutions for different systems be technological or be social. I also like to think about the settings where these are real. So that means sort of the algorithms that I'm going to design will actually go and become relevant hopefully the next day. But at the same time, I also like to think about why this is the right solution or why this is not the right solution. And many a times, right marriage of these things happen. And in some sense, the questions that I like to work on or think about are precisely the marriage of these things. So for example, starting from my PhD thesis, one style of questions that got me excited, this was circa 2000, where everybody in Silicon Valley was building their own favorite chip of algorithms. And these chips would go and sit into different network devices in internet. And the whole purpose of putting things on the chip was, you don't want to run them in software, but you want to run them in hardware so that things become fast. Because really, those were the times when we had just optical networks had been just realized fully, speeds were high, but devices were not able to keep up with things. And at that time, I spent time thinking about how to devise algorithms that can go in chip. And again, if you're thinking of putting logic on a chip, you got very little space, which means very little computation you can do. And you want to do interesting decisions at the nanosecond level. And as a wise man has said, your network is as good as the devices that are sitting inside it. So, which means that you have to be really, really careful in terms of what you put in your network devices. And so that actually led me to think about various types of routing algorithms and the memory algorithms and so on. Some of those actually I ended up working as a part of a startup, which I took a leave as a student, got back, spent a lot of time thinking about mathematically, abstractly, boiling down it back into actual algorithms in terms of how to do additions and subtractions in some sense, and then going back and working with some of the industries to try to see if they can be realized. Brought me to MIT. When I came around, there was around the time when it was just a starting point of where people suddenly were looking at all sorts of different sensors, realization that there will be need for infrastructure for storing data. And of course, the next step for somebody like me was to think about how to design algorithms that can scale with such a massive scale of data. So again, the question is very real, highly constrained, because now you've got massive amounts of data and your computational resources are limited fundamentally, relatively. So how do you design simple algorithms but that can do meaningful computation at scale? That led me to think of what are called gossip algorithm. I wrote a book about that. And in a sense, those are the things that are foundations of modern distributed databases. That's actually a key component on which all of these modern distributed computation systems are built upon. So actually, gossip approach is exactly what it sounds like. That is, what is gossip, right? For some idiosyncratic reason, I tell you something, which in turn you tell to somebody else and so on, and that's how the information spreads. Modern distributed systems are at some level unruly because they're so large. So designing architecture that are fundamentally centralized is very hard. So what you want to do is you want to go exactly the other way around, which is semi-anarchic, and one way to abstract them out is through these kind of gossip algorithms. Is any goal that you want to achieve through a collection of connected components is through these kind of semi-unstructured, semi-unruly communications. But hopefully if you did certain things right locally, then globally you would achieve the right things too. Okay. And anyway, so that was the type of things I looked at. Later it took me to some of the little bit of higher level data processing or statistical inference algorithm. They're called message passing algorithms for graphical models. And that's another 5 to 6 years of my life I spent about thinking about them, why they make sense and how to make them meaningful. And as we speak, for example, I've been contemplating how to use some of those algorithms to design hopefully world's next best optimization solver for a large class of quotes and quotes what are called hard optimization problems. In the middle, I started looking at questions which were related to extracting preferences from social data, which led me to understanding and asking questions about how do people make choices when they're presented with a bunch of options, which led me to questions related to how to think about people's choice when in a heterogeneous environment, or building choice model of people from all sorts of data that's out there, how to think about building that system at scale and then deploying it in practice.